right, guys, today we're going to go over analyzing characteristics of graphs. And some of the stuff you will hopefully have remembered, or at least they should feel familiar from previous classes, Algebra 1 and Algebra 2. And then we'll get to, so this is the refresher section, and then we'll get to the brand new stuff. But this stuff should feel at least slightly familiar. Okay. So the first thing we're going to talk about are x and y intercepts because those are important parts of graphs. The x-intercept is the point where the line or curve touches the x-axis. And the y-intercept is the point where the line or the curve touches the y-axis. And we write x and y intercepts as points. So they should be like in parentheses x comma y as the point. All right, so then let's look at some examples. X-intercept and y-intercept of this one. So first, x-intercept is where it touches the x-axis, so that's this point right here, and that point on the graph is the point 2, 0. Then my y-intercept is where it touches the y-axis, so that's down here. So that would be the point 0, -1. Same thing over here. This one actually has two x-intercepts, one right here, one right here. So it has two x-intercepts, one at 2, 0, and one at 4, 0. Then y-intercept up here at 0, 4. The most common thing I see is students will tend to mix up these numbers. So remember, like when you are graphing a point, x values go first, so how far it goes left and right, and then up and down. All right, slope should also not feel 100% new. There are lots of ways that you might have known it. Rise over run, y2 minus y1 over x2 minus x1, change in y over change in x. So the slope is the rate of change of the line. When given a graph, we can determine the slope by using the, change in x and the change in y in the following formula. Okay. So when we're going to find slope, the first thing that you can do is you can always, if there's 2 points on there labeled nicely, you can use those points, or if you find 2 points that are nicely. So like on this second graph, for example, like here's another nice point because it's at a perfect corner. Same thing with like this point down here. So even if the points aren't labeled for you, you can find values on your graph that cross at nice intersections. So let's see, from the points that we're given here, so my rise, if I'm just using the graph itself, if I'm going from this point to this point, it looks like I rise up 1, 2, 3, 4. And then run 1, 2, 3, 4, 5. And then your slope is rise over run, so 4/5. Down here, let's see, my rise is actually going down. And if I use we'll use the points that they actually give us on here. Remember, you read your graph from left to right. So this one, as I went, it was increasing, so my slope is going to be positive. This one's decreasing right here. And so my rise is actually going down. 1, 2, 3, 4, 5, 6. So I would say -6. And then it's still going to the right. 1, 2, 3. So that's positive. And that makes sense, right? -6 divided by 3 is -2. So that would be my slope. So if you have a line that is going up, then it has a positive slope. If you have a line that's going down, it has a negative slope. All right, there are some special cases for your slope, and that would be if you have horizontal lines or vertical lines that are right here. So for example, your slope here, I don't rise at all to get from this point to this one, so my rise is 0. My run to get from this point to this point is 1, 2, 3, 4, but that doesn't really matter because if you do 0 divided by 4, you just get 0, and so then that's the type of slope that we have for a horizontal line. Excuse me. Vertical lines, though, the rise is, let's just use the 2 points they gave us. So the rise is actually going to be up or down. I guess it doesn't really matter. 1, 2, 3, 4, 5, 6. Let's say it's down 6. Your run, though, it doesn't go left or right at all. It's 0. And when you do -6 divided by 0, as we learned from algebraically finding domains, remember rational functions are not allowed to have 0 on the bottom because dividing by 0 makes your universe explode. So this slope actually doesn't exist. We call this type of slope undefined. So anytime you have a perfectly vertical line, that has undefined slope. If you have a perfectly horizontal line, that's 0 slope. All right, and then we'll look at directionality before we get into some of this new stuff. So directionality is when you look at a graph, you need to be able to tell if it's increasing or decreasing. We read graphs from left to right. As you read, is a line going up or going down? If the graph is going up, then it is increasing. And if the graph is going down, then it is decreasing. Okay, so let's look at this one. I read from left to right, and I can just kind of follow with your finger or your pencil or your mouse. This graph is, as I'm going from left to right, is going down, so we would say decreasing. This one, my graph is going down, so I would say decreasing. And then this one, as I go from left to right, my graph is going up, so I would say increasing. All right, none of that should have felt brand new to you. This next stuff might though, and that's okay. This is the new stuff section, so here we go. All right, so sometimes our graph switches from increasing to decreasing or vice versa. So like up until now, we've only dealt with graphs that have gone direct, like only up and only down. But if you have a graph that does both, in this scenario, we identify the intervals during which our graph increases, decreases, or a new one, it could remain constant, which means that you would just have a line that's going perfectly horizontal. This would be constant. This isn't going up or down. We write intervals using a similar format to writing domains. So I'm going to show you some examples of that right here. So for example, here's this graph, and as I'm following it, right, and you can draw on your paper, feel free, it seems to be going down, going down, going down, going down, going down, until we reach this point, and then all of a sudden, it's going up, going up, going up, going up, going up. And so then we, on our x-axis, identify where those things happen at, all right? So this arrow means it went from negative infinity, right? I can keep going this way forever. So as I follow my graph, it'll come from negative infinity. And then to which x value does it change? So we look on our x-axis. Which x value does it change at? Well, it changes at 1, 2, 3. So we would say that from, we'll look at the decreasing part. So from negative infinity, because this line keeps going forever, negative infinity up until an x value of 3, my graph was decreasing. So negative infinity less than x less than 3. All right. This looks very similar to how we write domain. Notice there's a couple differences though. We don't need fancy brackets because we're not talking about a set of numbers. You're just talking about an interval. You also never need to worry about having or equals to symbols here. It's accepted across the math community that you could include them or you don't have to. I never do because I'm lazy and I don't want to write less. And then you don't need the x bar in front of it as well. Okay, so this is just describing the interval. So from everything from negative infinity up until 3, our graph was decreasing. Then for increasing, we look at it starts at 3 and then it starts increasing as you keep going this way in your graph. So we'd say that our graph is increasing from 3 to positive infinity. Is there anywhere on this graph where we have a perfectly flat graph for an extended period of time? Like this point, obviously, is where it changes at, but it doesn't have a set constant horizontal line, so we would just write none for this example. All right, well, don't worry, we're going to do more with this. Before we do that, though, we're going to throw in another new concept. So when looking at a graph, you need to be able to tell if the graph is positive or negative. So that's another characteristic of a graph you have to be able to identify. To do so, we determine which intervals of the graph fall above the x-axis and which intervals fall below the x-axis. All right, so if you wanted to draw this on your paper at all, any part of your graph that falls in this section would be considered positive, and any part of your graph that falls in this section would be considered negative. So let's do those with our intervals that we're dealing with here. I'll use some different colors. All right, so I'm just going to go through and highlight the parts of my graph that fall in the positive section. section. So from here to here, that happens. And then from here to here, that happens, right? Those are the parts that are above the x-axis. So I can write those as my positive intervals. So I would say from -6, because remember, we're looking at the x value where it starts at. So from -6 until -2. And then there's another one, so we'd say from 2 to 6. I leave myself a lot of room here, did I? All right, so those are both sections that are positive. Let's look at some negative sections. So these sections below are in the negative section of your graph because they're below the x-axis. So we'll have 3 intervals for this one. I better leave myself some space. So I would say from, well, this looks like it's right on the end. So -9 until -6. And then I would say the next section is from -2 until 2. And then from 6 until +9. Oops, not -6. There we go. So those are all the sections that are negative. Now we're also going to go back and we're going to look at increasing, decreasing, and constant. Well, right off the bat, I can see there's nowhere on this graph that has just a perfectly flat line. So I'm going to write none for constant. Don't worry, we will see some examples where we have some constant sections. But then I'm going to go through and do increasing and decreasing. So I think in my last example, decreasings were red. So starting on the very far left side of my graph goes down just a little bit right here. So I would say it's decreasing there. And then this goes up. Oh, and then right here we start going down again. Okay, and then this goes up. And then last but not least, we go down again right here. So my decreasing sections are actually going to be from, squeeze them in here, -9 less than x less than -8. That's just this first little part that's right up here. And then -4 is where I start to decrease again until 0. And then my last section is from +4 till 8. Lovely. So those are all in the decreasing section. If we do increasing, we'll do the other sections basically. So starting here, my graph goes up. And then starting here, my graph goes up. And then again, this little bit right at the end, my graph goes up. So my increasing sections, I don't know if you can see that yellow very well. I'll write this one in black. We'll say from -8 to less than x. So it starts at -8 and then goes until -4. And then it starts at an x value of 0 and goes to +4. And then my last little bit right here, just this little section that pops up, so 8 to 9. All right. Notice my inequalities are always exactly the same way. You have no reason to write anything different, so just keep little less than x, less than symbol squeezing your intervals, okay? All right, this was part 1 of this note packet, so go ahead, pause, take a break, and then we can come back and do part 2 together.